All right, let's start solving some trig equations. Now, I have my trig table and my ASTC chart labeled out here, but I also have a piece of paper in front of me, so if I scroll around or zoom in, I'm not going to keep kind of zooming in and out. So I'm going to do one video for problems 1 through 4. I will cut that video, and then we'll do a separate video for problems 5 through 8. And that's at least page 1. All right. First thing, for each equation, solve for all possible values of x where the domain is equal to 0 to 2 pi. Now, because both sides of this domain are in parentheses, or no, they're in brackets. Let me get the right thing said. They're in brackets. Both of the answers can work. You can have an answer of 0 and you can have an answer of 2 pi. Be careful with this. You may also see a domain, and I'm going to go ahead and write this. You might see a domain instead that would say that x is from 0 to 2 pi and parentheses. So that would mean that you can go from 0 up to 2 pi, but not actually include 2 pi in your answer set. So just be aware of the difference between these two domain sets. And yes, the domains need to be identified because these are cyclic functions or periodic functions. There's technically an infinite number of answers. However, because we are restricting the domains, we don't have an infinite number of answers. Okay, so I'm going to go ahead and zoom in on problem number 1. And this one is going to get off to kind of an interesting start already. Because this is negative, if we look at the trig chart, nothing in the trig chart's negative. All right. So I'm going to technically ignore the fact that that's negative for right now. And what I'm going to actually do is rewrite this as cosine of x prime. So this is going to be the reference angle is equal to positive root 3 over 2. All right. Now, what I'm going to do is basically invert this, and I'm going to think about, well, what radian measure, right, because our domain was in radians, what radian measure has a cosine value of root 3 over 2? And that gives me an x prime value and a reference angle value of pi over 6. Okay, so that's where we're going to start. Now, what are we going to do with this? Well, I do know in this problem, and this is problem number 1, right, cosine was actually negative. So on my ASTC chart, I want to identify where is cosine actually negative. And cosine is going to be negative. That is a really thick line there. Hold on 1 second. So cosine is going to be negative in quadrant 2 and quadrant 3. So and there's a bunch of different ways to do this. If you know your unit circle pretty well, you could probably do this in your head. I know that that's pi. All right. And then to put an angle into quadrant 2, I am going to back up off of pi, pi over 6. So I'm going to do pi minus pi over 6 to find this angle measure. And then in quadrant 3, I'm going to push forward pi over 6. So I would do pi plus pi over 6. So that's going to give me x values. Now be careful. This was the reference angle. This is actually the answers to what I'm going to do here. So pi minus pi over 6 is going to be 5 pi over 6. And pi plus pi over 6 is 7 pi over 6. Use a calculator, get common denominators, whatever you need to do. But these are the two answers that if you were to do the cosine of 5 pi over 6, you would get negative root 3 over 2. If you did cosine of 7 pi over 6, you would get negative 3 pi over 2. Okay, so that's problem number 1. And this is basically what we're going to be doing for all of these solving. All right, some of them are a little bit more detailed than this or a little bit more complex than this, but this is kind of the basic breakdown. I'm going to go ahead and slide over to number 2, and we'll see what kind of fun we get with that one. All right, it's another cosine problem, but in this case, cosine is not by itself, so I want to divide both sides by 2. So we're going to have the cosine of x is equal to negative 1/2. Now, immediately, I'm going to go ahead and change this to the prime. Cosine of x prime is equal to 1/2, which gives me a reference angle of, so let's check the trig chart. When is cosine 1/2? Well, that's going to be pi over 3. Okay. So now that I know that I'm dealing with pi over 3, all right, again, I'm a visual person, so this is where my little ASTC chart comes in handy. ASTC. And where is cosine? Remember, cosine here is negative. Well, it's the same place it was last time. So quadrant 2 and 3. Okay. But the angles are going to be a little bit different this time. Okay. So we still have pi here at 180. We're going to back up off the x-axis, in this case, pi over 3 units. So this is going to be pi minus pi over 3. And then we can push forward into the third quadrant. This would be pi plus pi over 3. So that's going to give me x values of, let's see, 2 pi over 3 and 4 pi over 3. All right, so problem number 2 is done. All right, I'm going to go ahead and slide on down to number 3 here. Number 3 isn't necessarily a difficult problem. You just need to know what to do. And right now you've got something squared. So basically what you want to do, and it's not equal to 0, so this is helpful. You want to factor this. So these two terms both have a common sign. So I'm going to go ahead and factor that sign out. And then I've got the sine of x plus 1 equals 0. Now, I'm going to do two little equations here. I'm going to do the first factor, the sine of x, equal to 0. And then separately, I'm going to do the second factor equal to 0. Now, the first factor, sine of x equals 0. If we look at the trig chart, it's not in there, right? There is no sine value of 0 in the actual trig chart. Instead, what you need to think of is the unit circle, all right? So we've got 4 major points in the unit circle. We've got this point, that's going to look horrible. Hold on one second. This point, which is 1, 0. This is 0, 1. What was this one? -1, 0, and 0, -1. Okay, so if I look at these, right, I've got zeros in all of them, but only 2 of them have sine value of 0. Remember, every ordered pair is cosine sine. So this ordered pair right here and this ordered pair right here are the 2 that have the sine value equal to 0. Now, where are they? This point actually has 2 answers to it. So you're going to tell me x is equal to 0. And the second answer is that's also the location of 2 pi. So this is a place where, because of our domain that is inclusive of 2 pi, you can use it as an answer. You would have both. All right, so 0 and 2 pi. And then this point over here on the negative x-axis is pi. So those 3 answers are just from this piece. Now separately, I'm going to figure out this part. So let's see. This is going to be the sine of x is equal to -1. Now I don't need to do a reference angle here because we're dealing with a -1. I just want to look at my coordinates here because that's where I'm going to find sine is equal to 1. So we've got +1 up top. We've got -1 down here. This -1 corresponds to, I'm going to slide these answers down just a touch. There we go. So this -1 corresponds to the radian value of 3 pi over 2. Now, if it helps you, I oftentimes, and I'm going to go ahead and zoom out for just a second, when I do my trig chart and then I do this little ASTC, I oftentimes, especially with these solving problems, will add in the extra bits. So these ordered pairs I'm adding in and the radian values for those specific points. Feel free to add what you need to. So problem number 3 actually has 4 answers to it. We have found all 4 of them. All right. Let's go ahead and slide over to number 4. Okay. So number 4 here, we've got the sine squared x is equal to 1/4. So everything in math has an opposite operation or an inverse operation. The inverse operation to squaring something is we're going to take a square root. All right, so square and square root cancel. We've got the sine of x is equal to, now we got to be really careful here. We did not originally have the square root in the problem, so we have to put a plus minus here. The other thing you're going to do is you can actually break the radical up into the numerator and the denominator separately. So the square root of 1 is 1, the square root of 4 is 2. So what we end up with is the sine of x is equal to plus or minus 1/2. Now, to keep my brain working basically in the right order, I'm going to do the sine of x prime. So my reference angle is just the positive 1/2, which gives me a reference angle of pi over 6. All right, now if I look at the unit circle, right, I want to talk about sine STC. Let me actually put the right numbers in the right places. All right. So we've got sine here that's positive, right? Sine is supposed to be positive 1/2. Well, that would be the top half of my curve here, okay? So let's figure that part out first. So if we look at in the quadrant 1 is your reference angle, right? It's just that straightforward reference angle. In quadrant 2, we want to push back off the x-axis, knowing that that's pi, so this would be pi minus pi over 6. So answers here, we've got x is equal to pi over 6 and 5 pi over 6. So that's the first two. Now, that was when sine was positive, but sine can also be negative, right? It's plus or minus, so both apply. Let's figure out what happens when sine is negative 1/2. Well, negative sine happens in your third and fourth quadrants. So in quadrant 3, we want to push forward. So we're going to take pi plus pi over 6. And this is the first time we've seen something in quadrant 4. This is going to be 2 pi minus, because we're trying to pull back off the x-axis here. So we're going to do 2 pi minus pi over 6. So those two answers would be 7 pi over 6 and 11 pi over 6. All right. So that's all four. And yes, there are 4 answers there. 2 for when sine is positive, 2 for when sine is negative. All right, I'm going to go ahead and close the video here. I know this is problems 1 through 4. Like I said, I'll do a separate one for 5 through 8. Please let me know if you have any questions or concerns about this material.